And the thing is, you usually have this kind of startups. They're presenting their solution. Everybody, oh, that was cool and stuff. But you don't have a real industrial application. We're going to change this today. Because now we hear from a company that is producing machines, how they use this technology in order to offer a better product. And I think this is a best thing we could do here on an innovation stage. So the next speech will be started by Sascha Schürmann, who is Technical Sales Director of Priminer Werkzeugmaschinen GmbH. And he will talk about his new ultrasonic series of Priminers. And he's followed by Oliver Georgi, who was presenting 2 days ago, Managing Director of Vibrocut. And I can't be more excited. Please, Mr. Schürmann, stage is yours.
Yeah, thank you for welcoming me. Thank you for having me here. Thank you for the great opportunity to show our product, to show our companionship with the company Vibrocut. And frankly speaking, a couple of months ago, I didn't know too much about this. I'm, for myself, in the business for 34 years now, and I didn't quite heard a lot of this technology before. So it was exciting for me to learn more about this technology, and then we decided we just implement it in our system, which makes it even more exciting. A little bit to myself, my name is Sascha Schürmann. I'm Technical Sales Director for the company Priminer, located in Germany and China. We are producing in China and developing mostly in Germany. So, the ultrasonic system combined with our system is, I understand that I will be the opening act and the main act will be my colleague Oliver, so I keep it short, try to keep it short. But any system is only as strong as the foundation, and our foundation is the C500. So, why hybrid machining? It combines conventional machine cutting with ultrasonic technology, as you can read. I myself, I come from the submarine industry, which usually deals with a lot of heavy and hard to machine materials like PN18, 39, 84, and for example, tungsten. For this opportunity to have this technology within our machine opens a lot of security, not only from the economic perspective, which is a big deal. You reduce cycle time, you are able to reduce cycle time, but from my perspective, from my old job, is you have the security not to break tools that already touched work pieces that had like hundreds and hundreds of hours of work in it. So this is one of the, from my perspective, one of the main advantages besides the economic part. For our machine, it expands the C500 capabilities to almost unlimited, because we have basically all the technology combined. We are right now also will introduce you to stir welding. It's called in English. I didn't forget the name. But it opens our machine to a lot of new possibilities for hard to machine materials. Like I already said, every system is only as strong as the foundation, and our foundation is our C500. What does that mean? We have a very, very price-effective machine, which combines entry-level price with high accuracy, with a lot of rigidity, which is the main factor for our partner Vibrocut, because the stability in the system, the accuracy in the system, and the agility is one of the main factors that makes this so special in this combination. Basically, it's a 5-axis machine, like most of the people know. We offer Fanuc, we offer Siemens, we offer also Heidenhain without any problems. So here we see what's the main advantage, for example, in combination to other machines. This machine is extraordinarily rigid. As you see, the machine is around 10 tons for a 500 millimeter table. That's quite a lot. And you see in the structure why we have 10 tons. It's very, very rigid. You have basically a C-frame with two big strong linear guides in y-axis, and all the moving parts from the XYZ axis are extracted from the working space, which makes it more easy. More easy for dust and to be protected for the machine. Other than that, we have a very rigid roller gear drive, cam drive, which you can see here, which combines high rigidity but also high agility. Yeah, of course, we offer a direct measuring system and an A and C axis open rotary coder. This is just template information. Like I said, I'll keep it short. I understand that I'm only the opening act. Mr. Georgi is the main act, I think, what's more interesting. We have machining dimensions, 700 millimeters in X, workpiece height 500 millimeters, 255 millimeters of payload is standard for this class, I think. We have ATC, standard ATC of 60 pockets and 90 and 120 in option. The diameter is, like you see, 80 millimeters and 125 and 8 kilogram of weight. We have several different spindle options. I show here two, one with 20,000 RPM, one with, this is not correct, this is 15,000 RPM with 129 Newton meter, which is already a lot for this kind of machine. We have 89 for the 20,000 RPM high accuracy spindle. So, I told you I will keep it short in order to have more time for the main act. And let me introduce you Oliver Georgi, and I give over to you. Thank you, Oliver.
Thank you. Okay, I go a little bit on the side. So at first, a small handover, why to use ultrasonics in a machining center in general. So one main point is when you use the ultrasound, you improve the process on the machine, and then you increase the precision and the performance on the workpiece. And one additional point is to increase the flexibility. So when you have such a machining center, it's useful when it is kind of a multitasking machine to have different processes on the machine. And with the ultrasound, we open the door for some high-tech processes, and like drilling of difficult-to-cut materials, grinding of brittle materials, and also the stir friction welding. And today I will to show you two applications we have also on the booth of Priminer inside the machine. So this will be the grinding of brittle materials like glass, ceramics, and silicon carbide, and also the process of stir friction welding, which is quite interesting because you can integrate a welding process quite easy in a machining center, and this is new capability for the tasks you can do with the machine. And also this processes opens high-tech branches like semiconductor industries, optics, aerospace, and oil industries. So one point at first, I will introduce the ultrasonic system at first, because it's quite unique on the market. So when you see our ultrasonic system, there's a small video, and the ultrasound is produced by a tool holder. Inside the tool holder, there's a so-called piezo actuator and a transducer which produces the ultrasound. And in addition, inside the tool holder, there's a special sensor who measures the ultrasound and keeps us a very control behavior of the ultrasound during the process. process. And the tool holder needs an energy supply to excite the ultrasonic vibration, and therefore we have a contactless energy transmission between a stator on the spindle front and the tool holder itself. And the stator is also integrated on the machine tool spindle of the Priminer machine. And one additional point is that also, although there's a stator in front of the spindle, the tool can be changed automatically and can be stored in the magazine of the machine tool. And because of our special design, we provide a unique performance, and because of the control with the sensor, also a very unique precision of the ultrasound system. And let's go forward to the stir friction welding. So stir friction welding is a quite unique welding process, which comes a little bit also similar from the name. So you have a shaft tool. We see it in the video here. Next time you have a shaft tool with a pin in the middle, and then the shaft tool drops inside the part, heats it up, but it does not melting, it's just plastified. And then a shoulder on the tool gets also into contact with the workpiece, and then it's plastified and two pieces are connected together, and then you have a feed and produce a seam. And the advantage of this process is that you have a very good quality of the seam. You have no pores inside, you need no gas or something like this. It's just produced by the friction and then the plastification of the material. And with this process, it's also quite easy to weld aluminum, and aluminum is usually not so easy material for welding. And you can implement such a technology just with the different tool and with the ultrasonic tool holder to the machine tool, and then you can combine it also with milling or drilling processes, which makes it quite flexible. But when you use such a stir friction welding process, then one point is also that there are some challenges when you use it. And this brings up also the ultrasonic device. So when you use the stir friction welding process, there are quite high forces, especially in the axial direction, in the Z-axis. And when you use the ultrasound, the forces are decreased significantly. So therefore, it is possible to have this process also in a conventional machining center. And another important point is also on this slide, when you use the ultrasound, then the quality of the seam is better. So on the left side here, you see two diagrams. One is the tensile strength of the seam you produce, and the other one is the elongation. And you clearly see by the colors, so red color is a high value, blue color is a small value, and then you have the conventional diagram, where you see that the quality of the seam depends on the velocity, feed velocity, and also on the RPM of the spindle. And usually it's not easy to find a good process window for the stir friction welding process. But when you see the diagram with ultrasound, it's nearly red, the completely diagram, and you see that's more easy to produce a good quality of the seam when you use the additional energy of the ultrasound. And then it's also the same with the elongation of the seam. So also there, it's useful to use the ultrasound to have a better quality. And this comes up because the ultrasound pushes an additional energy into the seam, and also there's a better mixture of the material. So that's why it works better by using ultrasound for such a technology. And let's come up with a next application. So this is grinding of glass, like silicon glass. This material is widely used in optics, and it's also used for special parts for semiconductors. And a very common shape in such machining tasks is like a pocket. You see here a workpiece, and the task is to produce a pocket inside this workpiece. Usually you use a shaft tool with diamond grains to produce such things, and you see it on the blue picture, like the workflow for the pocket. So you go in, and then you make like around the pocket to produce it. And on the left side, there is a diagram of the measuring of the force here. So you see it quite clearly. The force, the blue one is the producing of the first pocket. You see the workflow, and then there is a first level, and the next section is the second level, so a little bit deeper then. And this process is usually quite challenging because the the silicon glass is quite sensitive regarding process forces, and you see that the process forces increase after some pockets already. So you have the blue one, the first pocket, then the orange one, the second one, the gray one, the third one, and so on. And you see that the process force increase already, and in a further progress, it will be a problem for the process because of breakouts and quality of the part. And when this is the conventional machining, and when we now compare with the ultrasonic machining on the right side, you clearly see that all process forces go down rapidly. So again, the production of different of these pockets, and you see when you compare the blue one with the left blue one, the process force goes significantly down, and this is why the process reliability is much better. You have smaller cracks and breakouts on the material, and you can even produce significantly with higher process values. You can be more productive in this case. And when we compare the forces, again, for pocket 1, 2, 3, and 4, there the orange blocks are the conventional forces, and the blue ones are the forces produced by ultrasound. And you see that it's a dramatical drop of the process forces when you use the ultrasound, and this is a drastic improvement of the process in this case. So that's why we can say you use a standard machining center for such an optic application, and through the ultrasound it makes the machining center more capable for such a difficult or challenging process. And also one specific point to add, when you do grinding of materials, every time it's quite interesting to know when the tool gets in contact with the workpiece. Because when you use a grinding tool, there's tool wear, and it gets smaller and smaller, and it's very important for the accuracy that you know when the tool gets into contact with the workpiece. And usually there are specific sensors which are used in a machine tool to see when the contact occurs, but when you use our ultrasonic system, the ultrasonic system adapts to the process, and here you can see in our frequency signal when the tool gets in contact to the workpiece. And this makes it quite easy to have a good accuracy in the machine. So this was the last slide. Thank you very much, and we are happy to answer some questions.
Awesome. Thank you so much. Usually we should ask Mr. Schürmann on stage as well, yeah. But we don't have a microphone, but probably he wants to. So because this would be. But you can talk about the project anyway, Oliver. So there you take already place in a machine. So what are the first results? What does your customer say? How do they use it, the technology?
Yeah, okay, so I think the quite important point is we have, for the ultrasound, it's the model to equip also new machines, because we have like an interface to the machine tool, to the control, and working together with the machine tool supplier gives us the possibility to have a deeper integration. For example, when you see the contact between the tool and the workpiece, so it's a signal from the ultrasound system, but when we have a good integration into the machine tool, then you can use it quite easily and say now is the tool is in contact to the workpiece, and then it's possible to have it as a function in the machine.
What I was interested in when I saw that you're talking about the cooperation as well, is it like rather at this stage a cooperation, or would you say it's really a client that you sold the solution to? Because at the very beginning for you might be important as well to get feedback at this stage. How does it work?
Yeah, it's really like a cooperation, because our ultrasonic system is some kind of standalone technology, but on the other side, it's equipment for machine tools. And then you have an interface and you have certain points to adapt on the machine. So this is then the point of collaboration, especially when it goes for integration of the technology inside the machine. And then when you go for a customer and you have a technology on a machine, then it's also very important to have a collaboration, because the machine does the technology and the ultrasound is an addition. And that's why there is quite important, when you want to have a good result, then you have to collaborate in this case.
Let us talk a little bit about fields of application. So, I mean, we have saw now Priminer one kind of machine, let's put it that way. But I'm really interested in what kind of applications we are talking of. Where does it make the most sense?
Yeah, okay. So it depends. There are different fields that are possible. One field which is quite conventional, which was not the point of the presentation, is, for example, machining of aluminum, because there we have big advantages in the productivity. And then this is a case of automotive industry, for example. But when we go for such case like the silicon glass, then the application is in the optic industry, because many optic parts are produced by silicon glass. And another point is the semiconductor industry, where huge parts made of ferro-dur and semicon glass.
Very good. There was one question that I want to ask you last time. How do ultrasonic and oscillation assistant technology change the daily work in a machine shop compared to conventional processes?
The daily work. Yeah, hopefully it does not change too much, because our goal is to make it quite easy to use, especially for the operator. So it's quite, when the system is integrated, then it's just a little bit M code in the program, and for the operator it's quite easy to use. But when you look at the shop floor level, when the cycle times are lower, then usually this is the advantage, to have lower cycle times also.
One question that we haven't tackled as well is, I mean, you were talking about the silicon glass. Are there any other materials that you can mention that get easier to work on with your technology?
Yeah, so for the grinding, it's also like ceramics is a big point. There are different ceramics, hard ceramics and very hard ceramics. Also a topic is like jewelry. Jewelry is also hard to machine. And on the other side, there are difficult to cut metals like titanium, nickel-based alloys. And this is also important to use it here.
Very well. Yeah, that's what I had here, yeah. Then we were talking about areas. Where do you see the biggest growth potential? Because you just mentioned probably medical applications, but where do you see it the most in the future? Yeah, because this would determine a little bit your target group as well of machine producers, right?
So I think there are two different parts. One industry which is quite growing at this point is aerospace and space industry. Especially space is a topic for today. Yeah, and the other point is optic and semiconductor.
Okay. So, Oliver, from my side, all questions asked. I hope you don't have any more questions. Thank you so much, Oliver.
Thank you.
More than a pleasure to have you in that stage, here on stage. Say hello to Mr. Schürmann again. Thank you so much for presenting here. Enjoy the evening. Bye-bye.
You're welcome. Thanks.
Big applause, ladies and gentlemen.